Hey there, solar folk. I am the Solar Boy, and today we're going to be doing a repower job where we are replacing an old Fronius IG Plus inverter to a brand new Fronius GEN24 inverter. And actually, there's nothing wrong with this system that I know of, aside from the data logger up there has been dead for a couple of years because it got struck by lightning. But this inverter's still kicking after 14 years. And in fact, the reason we're doing this replacement at all is because Fronius has sponsored this video in order to get this customer a great deal on the brand new hotness, which is the GEN24. We'll take a look at this quick here before we start taking the old stuff apart. I have it sideways. That's not my fault. This is the GEN24. So the neat thing about this is the first hybrid inverter that Fronius has released to the United States, though it has been rolling around in world markets for a while now. A hybrid inverter means that you can use batteries with it, so that if your power goes out, you can keep using your solar and your batteries to keep certain loads throughout your house powered on until your power comes back on. If you live in an area where they charge you by time of use, which is, a certain period of the day is when most people use electricity, and then they just charge you based on how much electricity you use for those hours. This is great for that because then it can pump electricity back. You can use your batteries to offset certain periods of time of use. It's not applicable for my use case here, but for some people that's useful. But we're going to get into all of that later. So I'm going to put this away for now. We're going to start taking things apart and show you the process. First things first, obviously, we need to turn everything off. So we'll turn off our DC disconnect. We've got a breaker right there. Judging based on the meter now not showing anything, we should be good to go on the AC. Now, turning off this DC disconnect does not mean that there's no voltage in here. I gotta go up to the roof. I'm not sure yet if I'm filming up there or not. It's a little hairy, but I gotta go up there to disconnect stuff. Got our classic Solar.SOS box up here. Really don't want to drop the screws on this one. I'm impressed that theoretically we've had no issues with fuses on this site. Usually if you've got fuses in a roof box available to direct sun like there is right here, these fuses tend to blow a lot. But I'm assuming these are all fine. I guess we'll find out later. Before we disconnect these fuse holders, we want to just make sure that there's no amperage on them so we don't get sparkies. Yeah, that's fine. I'm probably not going to worry about disconnecting these. We don't have a circuit anymore, so if any of these wires touches, there's no power to flow through because the positives are isolated. So as long as we don't have any voltage down there, we're fine. What's really nice about this particular repower is that all of the wires from the roof come all the way down, meaning that in that fuse box they could have combined them into a single wire, but we have all four down here, which makes it really freaking easy to just swap in another inverter. And we'll see what the layout of the new inverter looks like once we get into that. But Fronius has historically always had a means of bussing together all of the inputs into a single one if you do have, one big number 6 coming down from your roof or whatever. Given how big this inverter is, you'd probably be multiple number 6. But it's also just really nice to not have to need that. Check all of our voltages. We can just go from positive to negative because all of these are bussed together. All these quote-unquote fuse holders are just bar fuses because everything's already fused up at the junction box. So we don't have any voltage from positive to negative. We can test to ground. There's going to be nothing on the positive and nothing on the negative either. So we are good to tear this thing apart. I am actually going to save a bunch of these bar fuses for later, and I'll explain why also later. Oh wait, I need to actually unscrew those. You should never use an impact for this, but it's getting not used again anyway, so. And with that, start removing it from the wall. While we're working on getting this one off, let's talk about some comparisons. This inverter, the IG Plus, which is 2 generations ago, is 96% efficient. The Gen24 is going to be 98% efficient. 2% added amount of power that you get from the panels into your usable power for your house, the grid, what have you. The other flabbergasting thing to me, this thing will only start up when it sees 265 volts from the array. But the new Gen24 starts producing when it sees 65 volts. That is, you know, might not be a lot. You'll get more at the beginning of your day, more at the end of your day. And, you know, it's not like you're producing much between 65 volts and 265, or probably 300 volts is probably the actual startup, like producing voltage. But 365 days of that, that's a really flexible inverter and gives you more power over the day. And the other reason why that's important, I'll talk about later with how they do MPPT tracking now. Obviously, the new one is going to be better at tracking how to produce from your panels, but we'll get into more of the nitty-gritty with that later. You gotta just... There we go. Ta-da-da! The other thing we're not using anymore is this data logger. The data logger in this generation was always extra. Actually, I do think you could get a card to shove in this thing, but a lot of people just opted for the one that goes outside. And then it plugs in using SolarNet, their protocol for communicating between inverters, and then daisy chain between inverters. But with the Gen24, it is always standard, always got a data logger in there. Even for the snap inverters, the last generation, it was always an option, but you didn't always get that. Now you just get it, like with a lot of other inverter companies. Now, as we think about setting up for the new inverter, a couple of things to notice. First, these have quick locking screws, so there's no torquing. It snaps when you've unscrewed it, screwed it to the proper position. That is really nice. I can't think of anybody else that's done this. I don't know why. Boy, that saves a lot of potential stripped screws and heartache. The other thing you'll note is that this no longer has a screen. It has a bunch of indicator lights and a central infrared button. It'll be easier to see later when we go to set it up. But you'll have your indicator lights, one button that you can use to interact with it, and that's it. A lot of inverter companies have gone this way because for older inverters I've seen on the IG Pluses and plenty of other brands, the screen is one of the first things to go, seems to be one of the hardest things to get right. Because if it's in the sun all the time, there's not really a screen out there that likes to be in the sun all the time. So you'll end up going to a site, the indicator light's on, but you can't see anything on the screen in order to understand what it's upset about. Because these new inverters are all so heavily app-based, kind of removes the need for a display as long as it has good connection with the portal, and the portal tells you what you need to know. Inputs are pretty similar to basically anything else you'll see on the market. You've got your PV strings over here, you've got your AC going out over here. This is going to be, and we're going to do this too, you can add an external receptacle to this thing so that when the power goes out, even if you don't have batteries, it can power a 15 amp receptacle. In here, of course, is your Ethernet. Got a Wi-Fi antenna, separation between your DC and your AC. So we want to be bringing up our DC over here and our AC over here, which is great because that's what our existing installation did as well. Sometimes things just work. Oh, and of course, if you're into battery stuff, that's your battery input right there. You've got 2 MPPTs and 1 battery. In terms of input areas, you could go all around this inverter. You can go in the side, bottom, other side. You got a lot of flexibility with that. Can't go through the back. Oh no, you totally can go through the back even. Look at that. That is clearly sanctioned by Fronius. So super flexible. Now, as we're plotting this out, this does mount on a back plate. So the bottom of the back plate does not match where your connections areas are. So make sure you're making those measurements properly. And you know what? We're gonna wing it with that measurement because I feel okay about that. It's gonna be really easy to move if we need to. I tell you what, I am so glad that they got away from what they did with the snap inverter where they had all of the wires sort of included in the back plate, because if you installed it barely incorrectly, there would be water entry, void warranty because you installed it incorrectly, which that's fair, but this prevents any sort of water entry due to installing the backplate incorrectly. Speaking of which, these inverters are now 4X rated. So you can install them in super humid environments as long as all your connections are also 4X rated, obviously. Let's get this dry fitted, see how it looks before we put in the other 2 screws. Oh, look at that. That is primo, as you might say. That'll go right in there. This one I'll need to loosen up, but you know, you don't really think about how small this is compared to the other one until it's on the wall. It's so much less deep, obviously way less tall. It's not even that much wider. I mean, it's wider by about 5-6 inches, but the entire footprint obviously is way less, and it's way lighter. Man, I don't want to take that off. That's so pretty. The only thing is this thing, I'm gonna need to extend this wire. Actually, I think I've decided I'm gonna put it up about as high as I can, because that way, if they end up doing battery stuff in the future, there will be more space under here for shenanigans. And you know I love them sunshine shenanigans. One thing I'm noticing is these tabs do like to bend out a little bit if you mishandle them, so do be careful about those tabs. They do bend back, but you know, there's only a limited number of times you can do that before things start breaking off. And of course, as far as weight goes, it's super light, again, compared to older inverters. Here is one of the cool things that Fronius says about these inverters in particular. Once those tabs are popped in, you should never have to take them back out unless you're decommissioning the inverter, because everything in this frame is replaceable. The power unit up here, you just got to take out the screws. Power unit can be replaced. The fan can be replaced. The pilot, which is their comms card, sort of the brains, that can be replaced independently. And of course the cover, which we haven't put on yet. So once you have your wires in here, you don't ever have to take them out unless there's something wrong with the wires. Even your DC or AC inputs, they have a tab that lets you pop them out in the back and would allow you to swap out the power unit. One of Fronius's big things is sustainability in what they do. So making all the parts of their inverter very easily and modularly replaceable definitely fits into that mission statement. And with that, we're done with installation. Decided to speed through all the installation steps and just give you the highlights on this one. First off, we talked about the connectors up here. These are Wagos. So if you are familiar with how Wagos work, those are Wagos. They have the brand imprinted on them. So no torquing, you lift the lever, you stick the wire up in there, you put the lever down, it's all good. Obviously you need to strip it first, right? All of these connections can take up to number 6 on this class of inverter, the larger class, which I think is like the 8 kW, 10 kW. This is obviously a 10 kW, except for the power point. The power point is what Fronius calls the source of power that you have when the power goes down and the sun's still out. You can still plug something in here. Anyway, for the power point connectors, these only go up to number 8, or at least that's what it says in the manual. Now, when you're connecting this up, there's some conflicting documentation in the instructions. They say only up to number 8 for these, but when you're connecting the ground, your ground from your outlet goes into your ground bar back here, and then you need to jump the neutral to the ground bar with a number 6 wire that has the ends of them permanently marked blue. Now, I don't have anything blue to mark these. We're just gonna let this be as it is. But keep that in mind. And I did successfully get a number 6 in here. I'm not sure you're supposed to. Once I clarify with Fronius, I will let you know and probably pop in on a green screen right here. For the Ethernet, you're only supposed to be using LAN 1 right now. LAN 2 is reserved for internal purposes. I would love to see this eventually become just another point where this acts as a switch and you can pass your network through and just daisy chain inverters like that. But for now, this doesn't do anything. Don't plug into this, plug into LAN 1. On the DC side here, I wanted to explain a little bit about what's going on over here. We have two what is called maximum power point trackers. Fronius's tech behind tracking the maximum power point of your panels is called the Dynamic Peak Manager. Now, this system is not complicated. It is a solar array that does not get shaded. All of the strings are exactly the same length, but I am putting 2 strings each on the 2 maximum power point trackers, and they will get adjusted independently of each other. You might be noticing here, if you are fairly new to the solar industry, is that we have black wires and we have white wires. This was how solar installations used to be done. They used to be grounded systems. And what that referred to is basically the inverters at the time used transformers. And transformers needed to have a reference to ground, so they would ground one, either the positive or the negative, so that they could operate correctly. These days, it's all done in electronics and you don't need that ground connection anymore. So it's an ungrounded system. And in an ungrounded system, the positive needs to be red and the negative needs to be colored black according to the code. I unfortunately do not have black or red tape for some reason, but somebody who knows what they're doing in solar is not going to look in here and be confused. I do have all of my wires labeled back here. And if you know the difference between ungrounded and grounded, you might also realize that I only have fuses on one set up there. When systems were grounded, you only needed to put fuses on the ungrounded wire. But now, because both sets of wires are ungrounded in the inverter, each set of wires needs to have fuses if you have over 3 on a maximum power point tracker. And here we are putting 2 in each, so we do not need fuses because only 2 strings are being bussed together at any given time. So short story is, we don't need to add fuses up on the roof, and I'm actually going to take away the fuses that are up there to increase reliability of the system with these bar fuses, because we don't need them. And if you don't need them, might as well increase the reliability of the system and not have those fuses accidentally blow when they aren't actually doing anything valuable. Okie dokie, our roof power is on. We're gonna start closing this up. And while I do, and while we get stuff powered back up, oops, that's the wrong screwdriver. While I get stuff powered back up, we are gonna talk for a minute about the power tracking. I know I've mentioned the maximum power point trackers, but it is worth getting into them further because there is a whole debate over whether string inverters like this or optimizers or microinverters are better at converting the power from your panels. And to do that, we're going to look at the power curve. First off, what is a power curve? Well, this is what that is. You have your kilowatts up here, you have your volts over here. So this graph is a symbol of if the inverter runs your solar panels at a particular voltage, say 300 volts, that would be about 4 to 4.5 kilowatts in this power curve example. This is a typical power curve without any shading, just straight up, it's a row of panels, sun's beating down on them. This is gonna be, it's gonna be a nice smooth curve like this. How power trackers used to work is that they would go from the highest voltage they could, be open circuit voltage. They'd go up and up and up and up to try to get the highest wattage they could out of this curve. And they'd kind of go back and forth here a little bit until they found, yeah, this is the best voltage. But there's a problem with that when you talk about shade, because shade can really mess up your power curve. So this again is your normal power curve. You've got your global maximum power point right here. And then once you start to have shade, it starts splitting up into multiple humps. So these are places where panel diodes start triggering, that kind of thing, where the old technique won't work as well for you, because the old technique would go, remember, it would go up that hump until it found like, oh, this is about the highest of that hump. That's the local maximum power point. But over here, this is a higher kilowatt reading, despite it being a lower voltage. But that tracker's not gonna get down to this valley and up. So what Fronius's Dynamic Peak Manager does is it scans for all those peaks constantly. 11 times a minute, I think. It goes across the entire curve, finds what your global maximum power point is, and produces there. And what we're finding is that this is as good or better than optimizers. Partially because optimizers use power all the time. Certainly if you're in a situation with full sun, optimizers are going to produce less power for you over time. And even in a situation where you've got diodes that start tripping, optimizers are not going to fix that for you, because optimizers are going to prefer to produce at the maximum output of that panel, which is going to be the part of the panel that has no diodes triggered on it. Anyway, Fronius has a whole white paper on this. You can feel free to take a look at it. I have that linked in the description, but check that out if you're curious about more. Real quick, something I forgot to mention is that these do have support for rapid shutdown. Notably, AP Smart is what they say that they work with. This site just has strings. We're not upgrading to rapid shutdown because holy crap, why would you? But if you need rapid shutdown, compatible with AP Smart. Couple more bits here. We've got our wire box cover on, putting our main cover on, and just like that, we're ready to turn the DC disconnect on, the AC disconnect on, and it's time for commissioning, baby. As with most inverter manufacturers these days, they have you use an app in order to set up the inverters, and the Gen24 is no different. You could do that with the Snap inverter, but it wasn't as promoted. But the app you want is called Solar.Start, and you'll log in with your installer account, go through, and we're gonna get started with setup. We chose our Gen24. We're gonna activate the access point, and to activate the access point, go over here and you just press that little button right there. It senses your finger, and now we're gonna connect via scanning. So we're gonna go over to this little QR code over here on the side. You know what, we're gonna connect manually because that is way back there. Do yourself a favor and make sure you write the passwords down for the next installer so that they have that access whenever they need that. So you type in your PV system name, we're gonna get all these things set up. Yes, we're gonna agree to a bunch of stuff. And if you needed anything other than Ethernet in order to connect to Solar.web, this is where you would do it. You can set up Wi-Fi, Ethernet, access point, whatever you need. After we set up the network, we need to set up the technician password. And once we get to device configuration, this is where you'll want to know how much power the entire system can produce. For ours, it is 4928 per MPPT. That's what the panel wattage is nominally. Just a note here, if you have connected your PV1 and PV2, your MPPTs, as a whole unit, like if you have one wire coming down from your roof that has multiple strings on it and you need to cross them across all your MPPTs, you need to select the PV1 plus PV2 connected in parallel. Otherwise, you're gonna have issues. We don't have anything in terms of backup power or load management yet, so we're not using any of these pins for anything, but this would be where you would set it up. Forgot, in the setup, there is a part where I said, we don't need any of these here. That was where you set up the PV point. And we also don't have any export limitations, so we're gonna move past that as well. Now we're gonna get this connected to Solar.web for monitoring. So we're going to turn off the Wi-Fi, and then it will allow us to continue. That's humming over there. So we're gonna add this product to an existing PV system. Okay, and we need the V code for the Gen24 inverter. And now we supposedly will be able to see this thing on the portal already. This is a very fast setup. Already we are seeing 5.85 kW coming out of this thing, which is great. So what do you actually get for adding your inverter to Solar.web? Well, a number of things. You can update your firmware, and you can get error codes on Solar.web now. Now, this is a long time coming. This is honestly a relief to me. And in my opinion, Fronius is a little bit late to the game on this part. But the other side of this is that they have a really good setup for figuring out what your error codes mean. You can now go to solar-sos.fronius.com and log in there in order to check your inverter model against a particular state code. And they have literally all of their state codes in here. Like, this is the resource that their level 1 techs use. And as a technician that knows what they're talking about and often wishes that I could just crawl through the phone that I'm talking to tech support on and just rummage around in their computer to figure out the answers myself, This is awesome. I can put in a serial number, it'll auto-populate the product, you put in your state code, and it will tell you what the issue is, what the troubleshooting steps are, and you can do this all without talking to tech support, period. So theoretically, you can go through this troubleshooting process and then open a case explaining you did all of these things, and then tech support could be like, oh yeah, we'll ship you a new part, which saves an immense amount of time. And you can be better prepared for going to site in the first place. Because if you have the error code remotely while you're doing monitoring at your desk, you can go right to Solar.SOS, type in your state code, and figure out what you need to be prepared to troubleshoot before you get on site. I know other inverter manufacturers have done similar things to this, but if this is really contains all of the state codes that you might come across, that is absolutely better than anybody else out there. Good resource, just flat out. And by the way, if you have a state code that you need to manually clear on the inverter, say you have an erroneous arc fault pop up, which you probably won't, I'll get to that in a second. You keep going back out to site, you don't want to have to go back out to site to charge the customer. You can have the customer come over here and just hold here in the button for 3 to 6 seconds and it'll clear. Even if you just need to have it cleared for like a day before you get there, that could be it's a really nice thing to be able to do. You know, I do have a soft spot for whacking an inverter when I'm trying to clear an arc fault, but you gotta admit that this is a little bit more demure. But on those arc faults, Fronius has said that this is the most advanced arc fault algorithm out there. Everybody's gonna probably say that, right? But here's the thing. Fronius is not only a solar inverter company, they also make welders. That's like a huge business for them, is welding. And guess what else makes DC arcs? Welders. Arc fault detection has gone through a lot of evolution over the last 10, 15 years. We've gone from needing to simulate an arc fault with like steel wool that is slowly pulled apart to arc and like capture that signature, to using more of a ring and ball method where you slowly separate them until you get some arcing, and that's more representative. But Fronius says that their algorithms that they're able to collect through their welding data both passes the ring and ball test and is as accurate as humanly possible. It's just cool. I find the fact that the welding and the solar come together to form a beautiful solution out of a problem that the solar industry has had for the last 10 to 15 years is great. It makes me happy. All right, I want to talk a little bit about the battery capabilities of this thing. And the first and most important thing is this does not have that yet. Let me explain. Any Gen24 you buy right now is not capable of using batteries. That's because that firmware is coming later this fall. How Fronius has this set up is that when the firmware is available, you'll be able to buy either a Gen24 or a Gen24 Plus, which includes the battery firmware. That doesn't mean that this will never be able to do batteries. It just means that we need to wait until this fall, buy the upgrade, and then add batteries, and you're fine. And you might be like, all right, hold on. The inverter comes with all the stuff it needs, but I have to still buy the firmware. Well, yeah, and this is what Fronius is going for here. Not everybody can buy solar and batteries at the same time. Some people will want to buy solar and then add batteries later. This is what that's for. So if you don't have the budget to add batteries right away, Fronius still wants you to be able to get a solar inverter that you can upgrade those capabilities later without swapping the entire inverter. So bring this in at a lower price point. You can upgrade the inverter from SolarWeb, then install your batteries, and you're good to go. Obviously, you'll need more components than just this, but that still all has to be worked out. I'm sure we'll get more information this fall about that. But what this is really meant to do is power a loads panel. So not the entire house panel, but a smaller panel that has more of your immediate needs. So like if you have a water pump, maybe you could throw that on here. Probably can't throw on your AC. That's probably too big of a load. This thing can handle 60 amps inrush, which is pretty darn decent. And it will settle out to a little less than 10 kW for continuous output from just batteries. If you have solar involved as well, that will up your capacity, I think, back up to 10 kW. But like I said, the idea is maybe you can put a fridge on there, maybe you can put on all of your lights in your house, your internet, you know, all the things that make it nice to exist during a power outage. But this alone is not meant to run your entire house. If you're looking for something to run your entire house, you'd be looking for an off-grid setup as opposed to a hybrid inverter. So any hybrid inverter you get out there is not going to be able to do what an off-grid setup does. Or if it does, it's not really how the inverter was originally designed. Off-grid setups are way more expensive, need a ton more calculations in order to make sure that your house doesn't lose power even when you have grid. Those setups are complex. Hybrid inverters are for making your life a bit nicer in the wake of a power outage. Also, I got this to work. Turn it off. After a minute or two, this green light should show up. There it is, right like that. I can plug my charger in there, but we'll turn it back on so we can keep producing. Last, let's talk about the warranty and how long these things we can expect to keep them serviced. The warranty is 10 years for parts and labor, so there's a small stipend for if you need somebody to come out to your house to fix something. Fronius will reimburse them some so they can give you a break on the repair. Once you register the product online, that'll give you an extra 2 years of parts warranty, and you can purchase up to 20 years of parts warranty. Now, I asked Fronius, well, okay, beyond the warranty, how long do you expect these things to be able to be serviced? Because there are other solar inverter companies out there where they've completely abandoned certain model types. If you need a replacement inverter, you gotta put in an entirely different sized inverter and completely, like, you're basically doing a repower job instead of just like swapping a top or whatever. And Fronius couldn't give me a number, obviously. It's hard to put a number on that, but they did point to the fact that even today, their original IG inverters, so the generation previous to the IG Plus that was here, they're still sending out parts for that. Obviously, you'd buy them because there's no way they're in warranty anymore, but they do still provide parts for them. And I would expect that, as with their previous product line, this has a very long tail when it comes to serviceability. As with, you know, it's Fronius' whole thing, is they're trying to be sustainable. This is one way you do it. But that's about it for my overview of installing and commissioning one of these things. Let me know in the comment section if you have any questions, especially around the battery stuff. Like, as we get more battery information, I might be able to come out and give you more information about all of that. So leave your questions down below. I'll try to answer as many as I can. Thanks to Fronius again for sponsoring this video, and please like and subscribe if you've enjoyed this. Your support is what gives me joy in doing these videos. I want to make solar as accessible to people as possible. And with all that, I'll see you next time.